Hi all. Today we are going to learn about software cost estimation. Estimating the cost of a software product before the development process is one of the prime concern of both the developer as well as the customer. So in this session we are going to learn what all are the models of software cost estimation and what all are the methods or the techniques used in software cost estimation by the IT industry, and we will go through the COCOMO model, which is one of the most widely used software cost estimation techniques in the IT sector, and we will deal with some of the numerical problems of COCOMO. So before going through all these technical contents, let's understand what is the need of software cost estimation in an IT industry. So let's go through this conversation between a project manager and then system analyst. So the project manager is asking to the system analyst to give the estimate of the project, and the system analyst is telling that he cannot give it right now because he have no idea about the user requirements. He haven't even gathered the user requirements, so it is not feasible at this stage. But the project manager is telling that you don't need to worry and I won't hold you to the estimate, you have to give me a rough estimate right now. And the developer is telling that sorry sir, it is not possible because you will put this in the plan and you will forget about this conversation between you and me, and whenever the budget goes beyond this scheduled estimate you will definitely fire me, so I cannot do it right now. This makes the project manager angry and he is telling that you have to give me a number right now, otherwise I will fire you right now. And then the developer is in trouble and he is just simply saying that it will cost $10 million. Then again the project manager is saying that that is too high, it is uneconomical, we cannot afford that. Then the system analyst or the developer is saying that if you already know the cost, then why are you asking me to estimate? So from this conversation we can identify the following problems in an IT industry. One of the main problem is the project manager will force the system analyst to give the estimate before getting all the user requirements. So the second problem is, though the project manager is forcing them, they cannot give an accurate estimate. Though they are not giving the accurate estimate, sometimes in real time the actual budget will go beyond the scheduled budget, and definitely this project manager will fire the system analyst who estimated this cost. So that is one of the main issue in a software industry. And the fourth problem is, if the system analyst is ready to give a rough estimate, then definitely the project manager will argue with them by saying that it is too high, you didn't consider the economic possibilities, all those things. Based on these things, there should be a standard possible manner to estimate the cost of a software project. For that we are forced to implement some software cost estimation techniques that we will learn in the next slide. The main need of software cost estimation is to accurately and precisely plan and schedule the various activities of development. For example, during the planning stage, the project manager can choose how many engineers are required for the project to complete so that it will be economically feasible. The next thing is, they can properly monitor the project's progress. In case if the project progress is not going as per the expectation, then they can do the necessary corrective actions. So for doing all these things, an accurate and precise cost estimation technique is needed. So let's learn what all are the cost estimation techniques that we are following in the real-time IT industries. Software cost estimation techniques are classified into three: algorithmic methods, non-algorithmic methods, learning-oriented methods. In algorithmic methods, the basic parameter or the basic metric we used for estimating the cost is the complexity of the algorithms that we are using. In non-algorithmic methods, we are not using the complexity of algorithms. Instead, we are using some other parameters like the experience of the developer, some other factors like the resources available in the industry, whether we have done any similar projects in the previous work experience, like that. So based on that we can estimate the cost. Learning oriented methods, we are using our previous experience in doing the similar projects, and based on those estimation values we will train it in a system and it will predict the value for the new project. For this prediction process we are using artificial neural networks, genetic algorithms, fuzzy logic, Bayesian networks, support vector regression tree, etc. Our syllabus is mainly focusing on the algorithmic methods, where the algorithm or the complexity of the algorithm is concerned as the primary size estimation metric. We are learning COCOMO and function point analysis in our syllabus. So before learning COCOMO, first we have to learn what a single variable model and a multivariable model. The software cost estimation models are classified into two. In a single variable model, a single variable or a single parameter is used to calculate all the desired values such as cost, time, effort, number of persons required to develop the product, etc. It will be in the general form C is equal to A into L raised to B. Here L will be considered as the size. We already know the size metrics of a software are lines of code or number of function points in the code or number of object points in the code. So this size will be considered as the only parameter required for estimating all the other values like cost, time, effort, etc. That is why it is called as a single variable model. A and B are constant, so we can directly get its values. Only value that is changing is the size of the software product. In multivariable model, as the name suggests, there will be multiple variables and factors to estimate the cost. We may consider the experience level of the developer, what all are the databases we are using, how many GUI screens we are designing. Such kind of many different parameters will be considered for estimating the cost. We are going to learn about COCOMO model, which is an example for single variable model, where a single unit or a single parameter is considered for estimating all the other parameters like time for development, effort, etc. The famous software scientist Barry Boehm proposed this COCOMO model in his famous textbook called Software Engineering Economics, which is published in 1982. The name COCOMO got from the abbreviation of constructive cost model. The first two letters of each of these words are derived for getting the abbreviation COCOMO. CO from constructive, CO from cost, MO from model. COCOMO predicts the efforts and schedule of a software product based on the size of the software. The size of the software is usually estimated in lines of code. For example, there will be 1000 lines of code, then we will convert it into 1 KLOC. KLOC means kilo lines of code. 1 KLOC is equivalent to 1000 lines of code. So usually we will use KLOC as the basic size metric in COCOMO model. Barry Boehm have derived three variants for COCOMO model: Basic COCOMO, Intermediate COCOMO, and Complete COCOMO. In order to estimate the cost of a software, he has categorized the softwares into three types: organic software, semi-detached software, and embedded software. So the person who is planning to estimate the cost of a project should first identify in which of these three categories our software belongs to. So we have to identify the features of each of these categories. An organic software is a software in which the development team consists of very experienced developers and there will be a very small team. So simply an organic team is a small team with experienced developers. A semi-detached software is a team consists of both experienced as well as inexperienced developers and the team size is usually moderate. So organic is somewhat lesser than semi-detached. Embedded means project with high level of complexity. It requires large teams to develop and there will be tight constraints to finish the project on time. The time required for or the complexity required for developing an embedded system is comparatively very high. Next we are going to learn how will you estimate the cost using COCOMO. There are three equations, or we have to derive three parameters. What is the effort required for developing a project, what is the time required for developing a project, and how many people are required to develop that project. So effort is calculated using A into KLOC the whole raised to B person months. Person month is the unit used in COCOMO. So here A and B are constants. I already told that COCOMO is a single variable model. Here the only variable that is changing is KLOC. A and B are constants. For example, if we have 1000 lines of code, then the equation will be in the form A into 1000 line will be converted to KLOC. So there will be only one KLOC. So A into 1 the whole raised to B person months will be the effort. Development time is estimated using C into the effort that we already estimated whole raised to D, and the unit is in months. We got the efforts in person month and we got the development time in month. So if we want to identify how many persons required, then person month divided by month, that means effort divided by development time will give the people required. In these equations we have seen 4 parameters or 4 constants A, B, C, D. The value of these parameters are different for the different categories of software. We have to learn the coefficient values. For an organic software, A will be 2.4, and for semi-detached it will be 3, and for embedded it will be 3.6. The B value will be 1.05 for organic, 1.12 for semi-detached, and 1.20 for embedded. The C value is actually same for all the 3 categories of software. It will be 2.5. You can even write the development time equation as 2.5 into effort the whole raised to D months, because the C value is same for all the 3 categories of software. Next, D. D is 0.38 for organic, 0.35 for semi-detached, and 0.32 for embedded. You have to by heart this table for estimating the cost of a software product. Next, we are going to learn about the relationship between effort and product size. So this is a graph which shows the relationship between effort and product size. From this graph, it is very clear that as the size is increasing, the effort for development is also increasing. For an embedded software where the constraints are very tight, it will drastically give a rise when the size is increasing. See, when the size is increasing beyond a point, it is directly or drastically change its effort to a higher peak value. For a semi-detached software it is somewhat normalized, and for an organic software it is comparatively less, because in an organic software the development team consists of experienced developers. Next, we are going to learn the relationship between the development time and size. As in the previous example, size will be recorded in the x-axis and the nominal development time is recorded on the y-axis. As the size is increasing, the nominal development time is also increasing. Though the organic software consists of very experienced developers, the development time will be comparatively less as the size increases. For a semi-detached team, the team consists of both experienced and inexperienced developers, so it will be slightly higher than the organic and less than the embedded. And for an embedded where the team consists of large number of developers and the constraints are very tight, it took too much time for development. So next we are going to learn a problem in COCOMO. This is the problem. We have to by heart this table for doing all the problems in COCOMO. Assume that the size of an organic type software product has been estimated to be 32,000 lines of source code. Assume that the average salary of software engineers be rupees 15,000 per month. Determine the effort required to develop the software product and the nominal development time. In order to solve a problem in COCOMO, first we have to identify which category does this software belong to. This software belongs to organic category because it is directly given in the question. Assume that the size of an organic type software. So it is clear that the type of the software is organic. So we have to use the parameter values of organic for A, B, C, D. So for calculating the effort, the equation is A into KLOC the whole raised to B. The lines of codes are given in 32,000 lines of code. So we have to convert it into kilo lines of code. So 32,000 divided by 1000, that will be 32. 2.4 into 32 the whole raised to B value is 1.05 for organic software. It will give us 91 PM. PM means person month. Next we have to identify the nominal development time, or the time required for developing the software. Time for development can be estimated using the equation C into the effort that we estimated in the previous equation, the whole raised to D. C is 2.5 for organic, so 2.5 into the effort that we estimated is 91 person month, so 91 the whole raised to 0.38 is the D value for organic software, that we will get it as 14 months. So the cost required to develop the product is, we require 14 months to finish the project. The average salary of all the software engineers in a software industry is 15,000 per month. So it is direct calculation, 14 into 15,000, that is 2,10,000. If you want to find out how many persons are required to develop this software, then it is very easy. We have 1 unit in person month and 1 unit in month. So person month divided by month will give the number of persons, that is effort divided by nominal development time will give the number of persons required to complete this project. So 91 divided by 14 will give the number of persons or number of software engineers required to develop this particular software product. Thank you.